So we have our CosmosDB set up. We created a database called MainDB, and it contains one collection called employee. Okay. What I want to do in this lesson is build a C#.NET app that is going to connect to this database and start putting data into it. Now, we're going to need a Visual Studio for this. I'm going to copy along. Remember, we used this program for the table storage. I'm going to copy the same basic structure of this and create it for CosmosDB. Now we start off by going into NuGet Package Manager, and we're going to install a CosmosDB package. Now in this case it's Microsoft.Azure.DocumentDB. DocumentDB is the API, this SQL API that we chose when we set up our CosmosDB account. If we chose Mongo or we chose Cassandra or something else, you're going to choose a different package. But we're going to choose the DocumentDB package, attach it to the project, and say install. Now we're going to include at the top, I guess the key one here is this using Microsoft.Azure.Documents.Client to get that reference into the program. Now on the table storage, we sort of set up the static variables to contain the storage account, the table client, and the table itself. And we're going to do something similar with CosmosDB. We're going to have the database name as a static variable, the collection name, and instead of having a table client, we have a document client. I also put the endpoint and the key from the storage account. If we go back to the portal and we go down to where it says keys, we can see the URI is being given to us and the primary key. Okay. Now there is this concept of a connection string, but unfortunately the Azure APIs don't just take in the connection string the way they do with table storage. You have to pass them in separately as an endpoint and a key. In the main body of the program, we just create a document client passing the endpoint and the key. So it's a lot simpler than what we have in terms of connecting to the storage account and then creating the table client as two steps. Now I've also broken out the insert and the query into separate methods like we did in the table storage. I'm going to open that up. Now you'll recall that in the table storage we created this employee entity and we just put the data as the row key. There's actually no extra properties. It just contains the partition key and the row key, and we don't have any other properties of this class. So for CosmosDB, I'm going to open up the employee entity. I had to make a change to this. We don't have this row key, right? There's no, it's not table data. It's NoSQL. It's unstructured data. So I put the first name and last name as properties. So we got the get and the set here. And I also added this toString element. So this is going to take this object and convert it into JSON. It makes things a lot easier. So if we look at the insert op, we're going to create this entity as a new employee entity. Now I didn't create the constructor, which I could have, but instead I'm just going to set the first name and last name based on the parameters being passed. Now I have an object. Now this is the sort of the key to it here in terms of working with CosmosDB. This create document asynchronous function takes in the database name and collection name. So remember we set these as statics. There's a create document collection URI method that will go off and create the proper name of this. And then we pass in the object. But then since this is a string, it's going to run the toString. It's going to serialize it. And because I'm calling an asynchronous method, I'm going to cheat a little bit and use the getAwaiter and then get a result in order to get the result. Because this is not a task and this is not an asynchronous method. We're doing this in a line here. Not ideal, asynchronous function, but that's what we're doing in this non-asynchronous method. And so this code here will insert. I'm gonna comment out the query for a second. Simply, this code here is going to insert these documents into the CosmosDB. we've got the name John Doe, Tony Soprano, and Richard Smith. So if I was to simply start and run this program, I would, it's a console app, so it's going to look and behave much like the other app. And basically just says press any key. We haven't done the reading element to this. If I go back to Azure, there's a thing called Data Explorer that will allow us to see inside of the database. We've got our main DB database and the employee collection. And if we look at the documents inside of that collection, we have 3 documents that were found, and I'm expecting John Doe, Tony Soprano, and Richard Smith. So remember, we created the employee object that just had first name and last name. And so CosmosDB has attached a number of things from timestamp, a unique identifier, etc., as additional fields that we didn't have to create or control. So these are basically what's being stored in CosmosDB. It's non-structured data which is being stored as JSON. It used to be called DocumentDB back in the day. Going back to here, now we don't have to insert. I'm going to comment out the insert commands. And let's look at the query. So now we've dealt with inserting the data. Now we want to read the data. So we're not going to be using this table query. I can actually remove it from the code. This feed options is actually a mandatory element. I was getting errors around a cross-partition query, so we had to construct these feed options. But very similar to what we did with table storage, where we had to construct a query, in the CosmosDB, we are very similarly constructing a query. It's to create document query. We create the document collection URI just like we did for the insert with the query options. And in this case, I'm looking for the record where the last name, it says last name Jack, but we should have nobody with the last name Jack. Let's pick Mr. Soprano here, okay? So we're looking for anyone on our document that has the last name equal to Soprano. And so we're expecting 1 record to be returned. So I hit F5 and I found first name Tony, last name Soprano. Okay, so this is the document that CosmosDB has returned, and press any key. So we can see here that building queries in CosmosDB is very similar to building queries in table storage. CosmosDB has the additional benefits of being a proper enterprise-grade, globally redundant system with promises in terms of service level agreements, uptime, response time, latency, etc. So we're able to use this for our real production applications in high-performance environments. Working with it, very similar to table storage. And we're just going to use the .NET functions that Microsoft provides. Now, I should also point out there are other third-party functions. We're not going to get too much into this because it's not going to be on the test. But if you were to go here and look for CosmosDB for not installed in the browse section, then you will find that there are some pretty popular third-party things that will allow you to manage CosmosDB. So other companies and other developers are coming up with frameworks that makes managing CosmosDB a little bit easier. But by no means is it necessary. We can obviously do it doing the official way. All right? So that's how you develop against a CosmosDB database.